Hello everyone. We are going to continue our class of Eurocode 7. We are on chapter number 9, a deep foundation. And previously we started uh, doing work examples, some design examples. In the previous lesson, we did one design example based on pile load test. Okay, we are going to continue with the examples, the second one then. And this time we are going for design using soil profile, CPT, okay, pile, model pile. So before we start, I would like to remind you this. In the previous lesson, we have learned that it was possible to design pile from CPT data, okay, CPT profile, and we can estimate both base resistance and shaft resistance. So, and by adding these two, we can obtain then the total resistance, okay? So the characteristic resistance can be obtained from those calculated resistance, okay? The calculated one are the result we obtain from the CPT, okay? Then we use this calculated result, calculated capacity to obtain characteristic value by then using correlation factors, okay? And then from the characteristic value, we can use some partial factor to obtain the design value. And that where the second Eurocode, the new Eurocode 7, I mean the second generation of Eurocode, is bringing a lot of innovation. So model pile procedure, this is what we are going to see to do, okay? So here is the example. It is a board pile again, and we have CPT profile. We will use design approach 1 and 2. Again, in the second generation of Eurocode, you don't have approach 1 and 2. Okay, but we will do this, the example in using the first generation Eurocode, and we will do it using the second generation because there are still some countries using the first generation. Okay, design situation. The pile is for building are each required to support the following load. Okay, this time we are going to design a single pile, okay? Because after doing calculation of the load from the structural engineering, we found out that each pile need to support this load. One, the characteristic permanent vertical load, 300 kilonewton, okay? And the variable load, characteristic variable load, 150 kilonewton. Remember, each pile of the building. So this time we are not going to find the number of pile required, but we will design one single pile. And designing this one single pile means we have to get the diameter or the section of the pile, and we have to get the length of the pile. Okay, how long the pile is. So remember also these are characteristic value. We will need to use some partial factors to obtain the design value of the load. Okay, these are characteristic value of the load, not the design value. Yeah. So we have a soil, the ground consists with dense sand beneath loose sand with soft clay and peat to 16.5 meter. Okay, so we are now describing the soil. Okay, the soil layers, and we have one CPT test profile, which is really not enough for a very important project. You need more than that. But anyway, we are going to do with it. So only one is available. Okay. So what you are going to do is what you are going to do is to find the design length of the pile, L. Okay. How long should be your pile to be enough? Then you have to impose a section, a diameter, for example. You can do it reversely, okay? You can say, okay, I want my pile to be this length, and you go to find out how the diameter you need. But that is not really a good approach. Yeah, it's better to fix the the diameter and then go and find out the length we need. So the geometry of the pile, we will come back on the profile, on the ground profile, okay? The geometry of the pile is then, as I said, diameter 0.45 meter, okay? So it means you have section of the pile with this diameter, and you want to know how long the pile need be to be able to support this load or these loads. You will combine them later. These load, how long your pile need to be to support these load. Yeah. And in this ground, because you have to precise, okay? If it was in another ground, maybe you will not get the same length, okay? So this is the problem, definition of our problem. So you know already what we have to do. This is enough already for you to design, to be able to design the pile for according to the approach 1 and approach 2. Yeah. Okay. So then let's go. First, the CPT means material property. Okay. One CPT. We have only one CPT. It's not really clear. I'm sorry about that. But we will try as much as possible to describe this data. This, if you check, you see it directly at you can notice immediately that you have soft ground at the top, and we have maybe more resistant ground deeper. Yeah. So because this is the QT value, CPT, QT or QC, and this is depth. Okay. So you can see from here to here, we have kind of relatively soft ground. So it is saying that the upper part, the upper soil layer, we have maybe from here to here, like or maybe here, from 0 to here, 11 meter, you have loose sand, soft clay, and some peat. Okay, this is what you have here: loose sand, soft clay, peat. From here to here, around here, maybe 11 meter. Okay, and then below that, you have 5.5 long, means from here to here, you have around 5.5 meter depth thickness of clay with peat. Okay, so it means you have 11 plus 5.5, it around 15.5 for soft ground. Yeah. So average, because in design, people really want very simple things. People don't want to struggle too much in design. So we will do an average, not anyhow. This average, as you can see, the cautious average. It means you will do average, but you will make sure to be conservative in your averaging. Okay. So if you do, unfortunately, it's difficult to see here, but the value here, I think this one is 5, and this one is like 10. Here we have 15, around that. Even me, I cannot see it very well. I'm sorry, huh? But anyway, if we do a average, we will get around 22.5 megapascal. So the line will be around here for this upper part. And then the lower part, medium dense sand, it starts from 16. Sorry, I said 15 here, but it should be 16, okay? 11, this is 11 plus 5.5, so it is 16.5. I don't remember what I said before. I think I said 15, but it should be 16.5, okay? You can this plus this, yeah? So, and then from 16.5, we start getting a dense sand, okay? This dense sand is starting. So, that dense sand is a strong layer, and it doesn't mean the thickness is 16 meter. It's saying from 16. It starts a depth of 16.5, okay? Start from here. We have dense sand. So we can also do another averaging with question, which is around 12.5, okay? As I say, this is 5, this is 10, and here we have 15. So if we do average, cautious average, we will get around 12 or something, okay? So then, as I said, in design, sometimes we don't really want to suffer too much. We don't want to struggle too much. We will just neglect the friction in this part of soil. Simply neglect it, okay? We will just ignore this part of the, in case of friction, okay? Because you know that the pipe, if you are designing a pipe, you have a friction, shaft friction, and the base capacity, okay? For this soil, this ground, we will consider that the upper part, the friction is almost zero, so we neglect it. But we will consider only the friction brought from by this part of the ground, okay? So remember, we have to average it, 2.5 and 12.5. I will put it, I will draw it, you will see. Here, I think this one is better even, yeah? So you can see 5, 10, and 15. So this is the first averaging we did, cautious average, okay? It's not the average you used to do, averaging, but we make sure that this average, like it too conservative, okay? 2.5. And then this one, 12.5, okay? This one, for in the dense, strong layer, okay? So now we will use only, and when I say only, it really only these two values. We will use this, or maybe only this one, to design the pipe. That is the what is interesting about using CPT. You need only the QC